Hey guys, you have a little different view this time. What I'd like to do, I've got 10-2 Day 1 notes ready to go. And on the front, what I want you to notice are some specific values of a polynomial. And so we don't know what the polynomial is, but we know that when you sub in 0 for x, you get 5 for y. And then we know the value of its first derivative at 0. So the slope of p at 0 is 7. We know the value of its second derivative, it's 11. Its third derivative at 0 is 13, and so on. So we've got information up through the fourth derivative. And what we're going to do is we're going to use that information to construct a polynomial named p. So I think it's going to be a fourth degree polynomial because I've got 4 values of my derivative. And I have written on the board on this side, which you can't really see, over here. I have those facts written on the board, but that's okay. You don't need to see those because those are in your notes. You need to see what I'm going to write on the board. So I hope you can see this. You might need to zoom in, I'm not sure. But up here I have a proposed polynomial. So here's what I think the polynomial might be. We're going to check it to make sure if it works, to make sure that it works. And then we're going to do any revisions over here. This is my revised polynomial. Okay, so first of all, I think that since the value of my polynomial at x equals 0 is 5, maybe the polynomial is like y equals 5. Or instead of y equals, I'm going to call it p of x. So if p of x is 5, I'm going to come over here and check it, and I'm going to sub in 0. If I sub in 0 for x, I get 5. Check your notes. Is that what we're supposed to get for p of 0? Yes, it is. All right, let's do a derivative on it. If p of x is 5, what's p prime of x? Well, the derivative of a constant is 0. Now, ready? Let's check it. Let's take our derivative that we just found. Let's sub in 0. What do I get? Well, I still get 0. Check it. Does this match the fact that's in your notes? No, it doesn't. In your notes, it says p prime of 0 is supposed to be 7. Uh-oh, I've got some fixing to do. So if p prime of 0 is supposed to be 7, the value of my derivative is supposed to be 7. Do an antiderivative on it. What do I get? The antiderivative, I'm going to call it p of x. The antiderivative of 7 is 7x plus a constant we'll call c. Now, do you know the initial value of your polynomial? You do. It's 5. So really, I think p of x should be 7x plus 5, not 5. Okay, so let's kind of start over. All right, so my proposed polynomial, p of x equals 7x plus 5. Let's see how we do. First derivative, p prime of x equals 7. P double prime of x equals 0. Let's check them. Let's take our original polynomial and let's sub in 0. So p of 0 equals 7 times 0 plus 5. Yes. That's good. Sub in 0 to your derivative. So p prime of 0 equals 7. Does this match our facts? Yes. Sub in 0 into your second derivative. P double prime of 0, I get 0. Does this match our facts? No. P double prime of 0 is supposed to be 11. So I think that P double prime of x should be 11. Do an antiderivative on it to get P single prime. P prime would be 11x plus a constant. Now, do I have an initial value for P prime? I do. My initial value for P prime is 7. So this constant should be 7. Do another antiderivative on it. P of x is going to be, okay, so 11x, I'm going to raise it, my power, I'm going to raise it, and I'm going to divide. 11 halves, x squared, plus, I'm going to throw an x on this 7, plus a constant. Do I have an initial value for P of x? I do, it's 5. So this constant is supposed to be 5. Okay, so now my revised polynomial is this one. This is much better than the one I had. So let's start over. New polynomial, 11 halves x. So P of x, 11 halves x squared plus 7x plus 5. That's what I think it must be. Let's keep going. Let's do some derivatives. So I've got P prime is 11x to the first plus 7. Second derivative, P double prime is 11. P triple prime is 0. Let's check them. So in P of x, I'm going to sub in 0. So P of 0 equals 11 halves times 0 squared plus 7 times 0 plus 5. Does this match our facts? Yes, it does. Sub in 0 to P prime. P prime of 0 equals 11 times 0 plus 7. Does this match our facts? Yes, it does. P double prime of 0 is 11. Does this match our facts? Yes, it does. P triple prime of 0 is 0. Does this match our facts? No, it doesn't. This is supposed to be 13. So P triple prime of 0 is supposed to be 13. Okay. Let's take that information and start to work backwards from there. So if P triple prime of x is supposed to be 13, then let's do some antiderivatives on it. That means P double prime is supposed to be 13x plus a constant. Do I have an initial value for P double prime? I do. My initial value for P double prime is 11. So this constant is 11. Do another antiderivative. So P single prime, all right, I'm going to raise it and divide. 13 halves x squared plus 11x plus a constant. Do I have an initial value for P prime? I do. Initial value for P prime is 7. So that constant is 7. Do another antiderivative. So, x squared, oh, it's going to get tight, but that's okay. You all know your antiderivatives. You don't have to really see what I'm doing. I'm going to raise it, x to the third, and I'm going to divide. So I get 13/6 x cubed plus 11 halves x squared plus 7x plus a constant. Do I have an initial value for P? I do. It's 5. Okay, that's That's a pretty good polynomial. So that's my revised polynomial. I'm going to run with it. So I'm going to start over. Don't worry, we're almost finished. All right, new polynomial. Oh, it's going to get squishy down here. I have P of x is supposed to now be 13/6 x squared plus, cubed, plus 11/2 x squared plus 7x plus 5. Ooh. Okay, so P prime of x, 13/2 x squared plus 11x plus 7. P double prime, 13x plus 11. P triple prime is 13. And the fourth derivative, you probably can't see this, but after the third derivative, I'm going to put a 4 up here in parentheses instead of going 4 tick marks. I'm going to put a 4 in parentheses, and my fourth derivative is 0. So here we go. Let's check them. So I've got P of 0, sub in 0, and I get 0, 0, 0, 5. Yes, that matches my facts. P prime of 0, sub in 0, 0, I get 7. Yes, that matches my facts. Double prime at 0, sub in 0. 0 plus 11 is 11. P double, yes. Triple prime, sub in 0, I get 13. Does that match? Yes. And the fourth derivative at 0, sub it in, I get 0. Does that match my facts? No, I'm supposed to get 17. So my fourth derivative that goes in parentheses at 0 is supposed to be 17. So let's make a different polynomial. P, 4 derivative of x equals 17. Do an anti on it. 17x plus a constant. Do I have an initial value for P triple prime? I do. P triple prime is supposed to be 13. So this constant is 13. Do an antiderivative on it. P double prime. I'm going to raise it and divide. 17 halves x squared plus 13x plus a constant. What's my constant for P double prime? It's 11. Running out of room. Do another antiderivative on it. P prime. Raise it and divide. To the third, squared, raise it and divide. Throw an x on it. There's a constant. Do I have a constant for my first derivative? I do. It's 7. Okay, last one. P of x equals, raise it, divide. Raise it, divide. And then my constant for P was 5. Oh, hope you can see that. I don't think you can. That's okay. You got the gist of it. There we go. So taking all that information, making a proposed polynomial, checking it by plugging in 0 into my derivatives, this is where it got me. I've got a 4th degree polynomial, and it has this initial condition, and it has all these derivative values at x equals 0. So what we're going to do is I'm going to take this polynomial that I have on the board, and I'm going to carry you back up to the front where I can do notes on the screen. If you're a person that has motion sickness, you might want to close your eyes for a minute. I don't know what this is going to be like. Give me just a second. Better. All right, I think that's good. Okay, so back to the paper notes, and I'm going to write out our polynomial, but just for fun, let's write it backwards. Well, I'll write it both ways. We got 17/24 x to the 4th and let's look at it backwards. Alrighty. 4th degree polynomial with all those properties. Now, what if we extended it? So can I come up with a rule to keep it going? So let's look at if n is 0, n is, like, I'm looking at this as terms of a series. Terms of a series. Oh, and I forgot to tell you one thing, one important thing. You need to take out your giant Post-it note. And your giant Post-it note I gave to you because we're going to build a list of fun facts. So I'm going to start them on the board somewhere. Fun facts for Calc BC. This is going to go on your yellow Post-it note. The fun fact that I want you to know is, first of all, do you know what factorial is? So you don't have to write this down, but 3 factorial means 3 times 2 times 1, right? You multiply down to 1. We're going to need to work with 0 factorial. So it turns out 0 factorial is 1. So 1 over 0 factorial is still 1. That's your first fun fact. 0 factorial is equal to 1. All right, let's go back to the notes. So, in general terms, can we kind of come up with how these things come about? So my 0th term, I've got p of 0. In my first term, I've got the value of my first derivative, and I've got an x to the first power. Okay, so let's describe some of this. So I've got the first one is p of 0. My second one is my first derivative at 0 times x to the first. And I'll go ahead and put these over 1. Plus, my second term, when n equals 2, where did this come from? Well, the 11 is my second derivative. My second derivative at 0. There's a 2 on the bottom, and I need an x squared. So you kind of starting to see some patterns. Next term, let's see, 13. Where did 13 come from? 13 was my third derivative at 0. There's a 6 on the bottom. Now 6 just happens to be 3 times 2 times 1. And this is x cubed, right? 13 over 6. The 6 is actually 3 factorial. 3 times 2 times 1. I used my third derivative, and I've got x cubed. So for this term, you can see that the 17 was the fourth derivative at 0. I need an x to the fourth, and 24 happens to be 4 times 3 times 2 times 1. So I think in general terms, we could just say, let's hang on, plus dot 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 plus. So what would our nth term be if we kept it going? Our nth term would be our nth derivative at 0. I would have times x to the n, and I would have whatever this nth derivative is, my denominator would be n factorial. That's how we would come up with additional terms. Whatever my nth derivative is when I sub in 0, n factorial x to the n power. Now, the way that we're going to write this is we're going to say what I get when I sub in 0 into the nth derivative. So first derivative is 1 tick mark, second derivative is 2 tick marks. When I get into higher order derivatives, we put the whatever derivative we're taking, we put it in parentheses in the exponent spot. So here's what it's going to look like. And this is going to look weird to you because you're not used to putting a number up here to note which derivative we're taking. But that's what this represents. This is whatever derivative we're using, subbing in 0 into that derivative. So we're doing the nth derivative, subbing in 0. I've got x to the n power over n factorial. So this works for, I'm going to do an easy one, like the first derivative. N is 1. The first derivative, sub in 0, x to the first power, 1 factorial. What's your next term? Well, your next term is the value of your second derivative, sub in 0, x squared over 2 factorial. What's your next term? And so on. Sub in 0 to your third derivative, x to the third over 3 factorial. Ooh, what about 0? Well, when you sub in 0 here, this is like gone, so you just need p of 0. You need the initial value, like 5 on the example that I just showed you. Okay, let's try some. It's going to get kind of long, this video. I'm sorry. So it says make a polynomial. Our function was, this was our function. So f of x is natural log of 1 plus x. And it's saying create a polynomial that mimics this function. We're doing this at 0. So if you recall back from section 10.1, this is going to be centered at 0. And we're gonna take it out kind of far. We're gonna take it out to fourth derivative so that our polynomial that we create, if I graphed it on my graphing calculator, would kind of mimic out away from 0. It would kind of mimic that function. So here's how we're going to do it. Our original is natural log of 1 plus x. Let's do our first derivative on it. First derivative is going to be 1 over messy times the derivative of the messy, which is just 1. Let's do a second derivative. Keep in mind that this is just x plus 1 to the negative 1 power. So I'm going to power rule it. So I'm going to bring negative 1 to the front, blah, 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 to the negative 2 times the derivative of the messy is just 1. So my second derivative looks like negative 1 over 1 plus x quantity squared. So this is also what it looks like, and I write it out like this because we're getting ready to do another derivative on it. And I think doing a derivative this way is easier than this way. So third derivative, f triple prime. I'm going to power rule it. Bring the negative 2 down to the front. That becomes a positive 2. This to the negative 3. Positive 2. One more, and you go to the fourth derivative. Okay, quick rewrite so that you don't mess up your fourth derivative. That's what your fourth derivative notation is supposed to look like. Okay, so I go negative 6, negative 4 times the derivative of the messy, which is just 1. So negative 6 over to the fourth. Okay, so it said go to the fourth derivative. I did. Now, in everything, in my original and in each of my derivatives, we need to sub in 0. So f of 0 is natural log of 1, which is 0. F prime of 0 is 1 over 1, which is 1. Double prime, negative 1. Triple prime, 2. Fourth, negative 6. Okay? Now let's see if you can create the polynomial. For the polynomial, we're going to call it p of x. I'm not going to call it f of x because we have a definite f of x. F of x is up there at the top. This is the one that's going to mimic it. This is what we have come up with that's going to mimic f of x. Here I go. I need, first of all, I need I need f of 0. So f of 0 I found to be 0. Now, for my next term, I need the value of my first derivative times x to the first over 1 factorial. The value of my first derivative times x to the first over 1 factorial plus. Next term, I need the value of my second derivative when I plugged in 0 times x squared over 2 factorial. Negative 1. N equals 3. So n equals 0, n equals 1, n equals 2, n equals 3. Need the value of the third derivative with 0 plugged in. That would be positive 2. 3 factorial. And the last one, because I went 4 derivatives, I'm going to have an x to the 4th. It's going to be the value of my fourth derivative over 4 factorial times x to the 4th. There we go. Now, let's simplify it. Zero, that's just an x, minus 1/2 x squared, plus, let's see, we're going to have to simplify this. 3 factorial, I'm going to write it out real quick. This is 3 times 2 times 1. So if this is 3 times 2 times 1, this 2 cancels with this 2, and I get 1/3. Minus 4 factorial. What's 4 factorial? 4, 3, 2, 1. So 4 factorial, the 3 and the 2 cancel with the 6. So this is going to be negative 1/4 x to the 4th. Okay, let me see. Did I do what it said to do? Construct a polynomial, check. That matches the behavior, check. I went through all of this process. At x equals 0, of course, we plugged in 0 every time. Through the first 4 derivatives, check. Okay, now, as complicated as it was to get there, what if it went on? Oh, hang on. Just so you know, this is called a fourth order Taylor polynomial. I'll talk more about Taylor polynomials later. It said construct a polynomial. We did. It's a Taylor polynomial. What if it went on? So what if it went plus dot, dot, dot? Can you construct the series in summation notation? And by that I mean how do you get each term? I can totally I could write the P sub n and all that up there, or I could say, if I'm going to start, I could start at 0 or I could start at 1. It doesn't really matter. How does this come about from n equals 0? How does this come about from n equals 1? How does this come about from n equals 2? How does this come about from n equals 3? So from n equals 0, I think I would need n equals 0. I need to increase it by 1 to get my coefficient, right? I don't know. I haven't worked this out yet. I'm totally winging this. Let's see. N plus 1 over... No, not n plus 1. 1. I think that's it. Oh, no, I need a negative 1 in there. And I've totally run out of room. Hold on. If I'm confusing you, just give me a minute. I'll make it better. I've got to alternate it. And I want it to start on a positive. There we go. I think that works. So I need to alternate it so that it's positive, negative, that this does that. And double check if I start at 0, this becomes a positive 1. Check. And then I always have a 1 in my numerator. The denominator, if this is my 0th term, I need my denominator to be 1. When n equals 1, I need my denominator to be 2. When n equals 2, I need my denominator to be 3. When n equals 3, I need my denominator to be 4. Also, when n equals 0, I need my exponent to be 1. When n equals 1, I need my exponent to be 2, and so on, and so on. So this would be how I would get each consecutive term if it went on. This is the Taylor polynomial. This is what it looks like as a series using summation notation. Now, for the next one, I know you all can do trig derivatives. So I went ahead and did the math for you because I knew this video was going to get kind of lengthy. So it said, you got sine x is our function. Let's make a polynomial that follows it out pretty far. So let's do 7 derivatives. I did them. I subbed in 0. I think you can trust me on the math. Ready? Let's make the Taylor polynomial, and then let's see if we can turn it into a series. So you might want to pause it and copy all that down real quick, or just screenshot it or something. So I'm going to go f of 0 is 0 plus the value of my first derivative over 1 factorial times x to the first. The value of my second derivative over 2 factorial times x squared. Third derivative, 3 factorial x to the third. Fourth derivative, 4 factorial x to the fourth. Fifth derivative, 5 factorial x to the fifth. Sixth derivative, 6 factorial x to the sixth. Seventh derivative, 7 factorial x to the seventh. And you can see that we need to simplify some of these. We're not going to multiply all these out. We're just going to keep them as factorials. They're going to get too huge. So you can see this term disappears, this term disappears, this term is going to be negative, this term disappears, and so on. So my 7th order Taylor polynomial condenses and simplifies to look like this. X minus 1 plus 1 over 5 factorial x to the fifth minus and I'm going to stop it there because it told me to. If I wanted to say, hey, this represents sine perfectly, then I would have to say, you got to keep it going. But it told me not to. It just said go to the seventh order. So that's my seventh order. See, I noted it. My seventh order polynomial that mimics sine of x, centered at 0. This is the Taylor polynomial. And then the Taylor series. So let's figure out, how do we come up with these terms? Well, let's kind of investigate a little bit. Sometimes I need to write them out. N equals 0, n equals 1, n equals 2, n equals 3, and so on. Well, the first thing you're going to need is you're going to need an alternator. So you're going to need that -1 that keeps being raised to a power so that you can alternate back and forth. So we're going to need -1. We need it to start out positive, so let's start it to the 0th power. Now, we have to come up with our fraction, and we have to come up with our exponent. Let's do the exponents first. For the exponents, this is n to the first. This is x to the first, x to the third, x to the fifth, x to the seventh. They're raising by 2. They're increasing by 2 each time. It's kind of like a linear progression with a slope of 2. Linear progression with a slope of 2. So maybe our x should be x to the 2n. What do you think? Maybe, since it's got like a linear progression and it increases by 2. When n is 0, no, I don't like it. It would be x to the 0. I need x to the first. Does that work? Can I just add 1? Let's find out. When n is 0, this becomes x to the first. Check. When n is 1, this becomes x to the third. Check. When n is 2, this becomes x to the fifth. Check. Okay, we are so almost there. So we've got how to get it to alternate. We've got how to get our exponent on our x. Now, the common theme here for the numerator is 1. What's the denominator? Well, the denominator is the same as the exponent factorialed. If I can use factorial as a verb. I don't know. I'm going with it. So it's 1 over 2n plus 1, same as my exponent, factorial. This is how we represent the series. This says, hey, if it kept going, this is how you get all your terms. That one stops at 7. Okay. Whew, sorry, that was extremely long. Good news. I had thought about combining 10-2 day 2 with 10-2 day 1. So I'm hoping that means that you'll kind of catch a break, from here on, and the videos won't be that long. Fingers crossed. I'll do my best.